Hello and welcome back to Fullerton College Pre-Press. This is your professor, Ben Hewitt. Today we're looking at PIA's Task 5 Module 2, 5.2 if you will, talking about paper. One of the more important chapters in both semesters of pre-press is this right here, because in the end, the substrate you print on has a lot of sway over the final product and how it turns out. Choosing the right stock is huge. Choosing the wrong stock will ruin you. All right, or at least your job. And by job, I just mean that project. Hopefully not get fired over it. Okay, I'm going to try and dig myself out of this hole and pull this foot back out of my mouth, and let's get started. So the PIA would like us to look at how paper is made, because that does actually affect how it performs. And we'll talk about what the weight of the paper is and how you specify that. Talk about paper grain and what it does for you. Talk about the importance of bleed and margins. Ooh, bleed. If you get only one thing from me as your teacher, and if you decide you're going to forget, or if you don't decide, if you forget literally everything from my class but retain only one fact, I want that to be bleed as the only thing you remember. If you remember only bleed, you're already well on your way to success in printing. And lastly, you'll look at the difference between sheet-fed and web-fed press configurations. Hint, one feeds sheets, the other feeds webs. Let's move on. So for almost everything you produce, most things that we print come out on paper. Yes, there's specialty printing. Yes, people love their custom printed cell phone cases and t-shirts. No, that's not the majority of the market share. Most things being printed are still paper. Books, magazines, junk mail, junk mail, junk mail. Sorry, my job was junk mail for a while, so it sticks prominently in my head. But all sorts of things on paper. Paper is still our main substrate. So again, not everything, but most things are printed on paper. Now, the size of the paper and how you handle it have to be considered before you can figure out your project. You need to understand how it's going to end before you start it out from the beginning. So let's talk about paper and how it's made. Paper is made from cellulose fiber, and most of that comes from wood pulp. There are other sources out there. While you make paper, the manufacturing process makes it turn into what it's going to be. I know it sounds silly, but the process itself leaves some indelible marks on the paper and creates characteristics that come from how the paper has been made. Paper that's made in the traditional ways acts differently than paper made on a modern papermaking mill. First, you need wood pulp. Yay, pulp. In fact, if you guys heard, I mean, this is the old movie, you've heard of the phrase pulp fiction or pulp adventures, talking about the kind of 1930s era adventure novels of tramp steamers and people getting lost in the jungle, or dangerous damsels and what do you call them? Entanglements with organized crime and gangsters in the streets of Chicago. Those are all called pulp novels because they're printed on pulp paper, the cheapest possible newsprint, just to get those novels out there and make them cheap. They're like your dime store stories that you read. I have a soft spot for pulp adventures. Anyways, so pulp. Pulp is chewed up wood. You take down trees, you cut them down, or you take remnants of trees from wood making sawmills, and you grind that up and mash it and chew it. And what's basically almost a giant spit wad made out of wood. It's crunched up, mashed up, applied to heat and chemicals and pressure, and it squeezes out as pulp. Then it goes into something called a head box. A lot of water is added at this point. So it's 1 part of wood to 200 parts of water. So it's really a very liquidy slurry. And it's bleached in here as well, because wood, and depending on your source, is not all that white. And honestly, in the end, if you're trying to do color printing, you need the most neutral, whitest, brightest paper possible to allow you to print the most colors possible. So there's always this, you're chasing this dream of that perfectly neutral, perfectly white paper. And so you bleach it at this point to get out the imperfections of the wood. And sometimes, depending on how cheap your paper is, sometimes they use stuff like leftover bark and leftover less desirable wood that's darker in color or more cast to a color than more of a neutral one. So anyways, lower quality papers will have more junk in them as far as what they're grinding up, and the higher quality papers will have less, but they're almost always bleached to try and at least make it serviceable, because you're looking for that high contrast. Even if it's black and white printing, you want to be able to see that ink against the paper. And if the paper's speckled and dark, you're not going to read the words. Anyways, You pump it into a machine called the head box. It's then squirted through the head box out onto a wire belt. The wire belt is a long conveyor belt made out of wire mesh. And it kind of looks like a screen door if you look at it really closely. And it squeezes out onto this, and it will then continue to move along this. And the wire belt, it's being drained and pressed while it's on it. Anyway, the opening that it squirts through is called the slice. And it's kind of like a giant tube of, what do you call that stuff? Like a frosting nozzle when you squeeze frosting on the cupcakes. And except that it's paper pulp and it's squeezing out into the belt. Now, the grain direction happens at this point. Because it's being squeezed through this nozzle, the wood grain that's still in the paper seems to align itself along the direction of travel as it's getting pushed through the slice. And that's where paper grain comes from. We'll talk a little bit more about what it is in a few minutes. Ooh, the Fourdrinier paper machine. Not my favorite word of all time, but getting there. Fourdrinier. Fourdrinier. What a cool word it is. Anyways, so this is the machine that makes paper. This is an American invention, and it's worldwide now, but we made it here. So the wire belt that might not be made out of metal wire, maybe a plastic, could also be bronze, is part of the machine. And this machine, as you can see in the diagram here, and hopefully you've seen in our little extra educational video, which I've posted with us to the Canvas class here, you can see that all these different rolls and the wire belt has something called suction boxes underneath. The suction boxes are what they sound like. They're vacuum cleaners. They help suck the moisture out of the paper. Because remember, you're talking 200 parts water to 1 part paper pulp. It's extremely liquidy, and it gets dried down here. One of the reasons you make it so liquid is you can get a very thin sheet out of this. And there's different rollers, dandy rolls and crouch rolls, and all of these things help smooth, flatten, and press the water out of the paper. This also leads to the fact that you have 2 sides to your paper. Although super high quality papers do a good job of covering this up, on cheaper paper it's more apparent, but it's always there. All paper has a good side and a bad side. They call it the wire and the felt side. The wire side is the side that touched that belt as it went through the machine. The felt side is the side that sits up on the top and is all nice and smooth and only gets touched by smoothing rollers. You guys have actually seen this in your lives. Think school, actually. If you buy a pack of lined notebook paper, you have yourself the light side or the front side and the back side of the paper. You'll notice that on the front side of your notebook paper, those little cyan light blue lines you're using to write in your college rule, or maybe wide rule if you like your wider lines to write on for bigger handwriting, it always looks so crisp and neat and precise on the front of those papers. But when you flip to the back side of the notebook paper, you notice that your pink margin and your blue writing lines are all thick, like someone wrote them with a Sharpie and they bled out, expanded, and just made this big blah on the back. Also, you might notice if you write on it in pen, your writing stays neater on the front, and on the back it tends to kind of expand and look messier and sloppier because it's more absorbent, because there's a rougher side on the back than the front side. The front side's all nice and smooth and polished and oh so lovely, and the back side is okay. Anyways, it's visibly better on a lot of papers. The front side is a better quality than the back side. There are other processes that are done sometimes to make the back side almost as nice, but typically speaking, you're going to see a difference. Anyway, editing back in here, I tried to show it on camera and it just doesn't show clean enough to show you that it's messy. Sorry, my video recording camera is not good enough to show the difference. So hopefully you can find a sample of notebook paper yourself to see the difference between the wire and the felt side, so you can see how one side is much smoother than the other and that's effect on printed ink. Sorry, I wasn't able to show it. I really had hoped. So two-sided is a thing that people don't necessarily like. It makes paper less usable. You can't, well, cheap books can be this way, but good books don't want to be this way. You might also notice the same issue, by the way, in like cheaper paperback books. Some sides of the paper might have thicker looking letters than the other side. One side will look all clean and crisp. The other side will look really blah and bolder than necessary. And that's also due to this, because ink absorbs into the wire side more because it's a rougher surface. It's more like a sponge, and that's like a smooth surface to sit on top of. So you get more dot gain on it. Anyways, modern improvements in paper make it so you can barely see the difference. In fact, I've noticed, I was trying to find good samples to show you on the video, that more recent notebook paper even has less of a noticeable difference between the front and the back. So after this, you got the dandy roll and the suction box. When it's on the belt, the dandy roll helps squish it out and flatten it and make it a uniform thickness. And the suction boxes pull the water out. We kind of talked about that already. When it comes off the wire belt, it goes through a couch roll. And this helps squish it down into its last thing, helps transport it down to where it's going to be. So it goes from being on the screen where it's sucking the water out to the press section where it's going to be squished and squished and squished until it's the right size. And so here in the press section, there's a bunch of rollers against each other with the paper in the middle. And the rollers roll and there's pressure being pressed. And it's kind of like using a rolling pin on cookie dough. It just makes it thinner and thinner and thinner the more it rolls, and smoother and smoother and smoother. They also help make sure that it's not really wet in the middle and dry at the edges, but keeps it moist throughout so it can dry at the same rate. If it dries at different rates, you're going to get some weird paper with a not flat surface. And last, there's a drying section where it goes around heated cylinders to help evaporate the last of the water out. This drops the moisture content down to 2 or 8%. And that's down from 99.5% originally. I think my math might be a little bit off, but basically when it starts out in that pulp, in the head box and it's pulp, it is more than 99% water. By the time it's done, it is less than 10% water. So it really does dry it a lot. Then you have paper coating. You can add coatings to your paper. That lets you have stuff like bright, smooth surfaces. Sometimes it's not shiny, but matte coated. By the way, I really like matte coating. I know it's not quite in favor as much as it was 20 years ago, but when it first came into fashion, you can see all the paperback books suddenly switched from shiny covers to dull covers, but they're still coated. Anyways, coating, you add stuff to the paper to make it smoother and nicer and brighter and better looking for printing on. Gloss is the most common, with matte a little bit less common, and there's some other types of weird coatings you can do too. Oftentimes they'll use clay as a whitening agent. And that sounds weird, but there's something called, there's a white clay out there that gets used for whitening. I know of this for many, many nerd reasons, including but not limited to the fact that in the old days, like think the Napoleonic Wars, and you always saw the soldiers with those white belts that they're wearing to hold their ammunition and their bayonets and stuff, the white X on a British redcoat. That white X is a leather belt, and it's kept white by rubbing white pipe clay, as it's called. They used to make smoking pipes out of it, onto it, and the whiteness of the chalky clay goes into it and makes it white. The same thing's used in paper. It's white clay. It also makes it smooth because you can smooth out a clay, and it helps it have a very nice surface. There's also, of course, that everything is these days, more polymer answers to the same riddle, where you can use plastics and such to coat it and make it smooth, shiny, and durable. So coating, this is stuff that when I started in the printing industry, I saw more often, and you're not going to see as much anymore. It's getting a little bit more rare nowadays to find this stuff, but it still does exist. And we'll talk about that in a second here. Because you can have coating on one side or two sides. So if you're ever looking at a paper package and you see the acronym C1S, that means it's coated on one side and the other side is uncoated. This is one of my favorite images to show because anytime you see what ink does on paper, it always makes me happy. Those are very useful things to understand because we're not just talking about what graphics are fun and what advertisements people respond to over here in the printing classes. We're talking about what things survive and what chemically, physically happens when you produce these things out into the real world. And so how ink acts on paper is delightful. The more you understand the materials of what you're working with, the better the outcome. Anyways, ink on coated surfaces, ink rides on the surface. It does not soak into the paper very much. As a result, you get brighter colors. On uncoated, it soaks in a bit and it mixes itself with the color of the substrate. Commonly, it makes it look a little bit more pastel. You need a lot more concentrated pigment to achieve the same color on coated stock than you do to achieve on uncoated. Other way around, sorry. Cat's got my tongue here. Uncoated stock requires a higher concentration of pigment than coated stock does. You can see this as well if you ever look at the differences of the Pantone inks libraries. The uncoated inks are much more concentrated than the coated inks because they know they're going to be diluted by that paper color. Just how to make that really good Coca-Cola you can get only at McDonald's, they actually they calibrate their syrup to water blend when they're mixing their soft drinks to account for the ice that's going to be in the cup. Nobody else seems to do that but McDonald's. And it turns out that their Coke is kind of the perfect Coke, isn't it? As much as I'm ashamed to admit actually eating there sometimes, they do make a good soft drink.